Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 5C. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Solistic LLP, it's my great pleasure to welcome you to the 8th World Conference on Smart Trends in System, Security and Sustainability, World S4 2024, London, UK. The 8th version of the conference is being organized in a hybrid mode. The physical event was organized yesterday in London, UK, and the virtual event is being held through Zoom from 24 to 26 July 2024. I hope you will enjoy the knowledgeable and interactive session throughout the day. In this session, we have 6 presentations. Each presenter will be given 12 minutes for presentation and 3 minutes for question answer round. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants to stay connected with us till the closing remark. If you have any query or any update, you can write it to me in the chat box. Further, just before we get started with the session, I would like to introduce you with today's session chair. Today, Dr. Prashant N. Mahale, Professor and Head of Vishwakarma Institute of Technology, Pune, India, will be being with us as a session chair. He has more than 19 years of teaching and research experience. He's a reviewer for Springer Journal of Wireless Personal Communication, also reviewer for Journal of Engineering, Science and Technology, School of Engineering, Taylor's University. Sir, kindly motivate our participants.
Good morning to all. Good afternoon to all.
Thank you, sir. Now, moving towards our next session chair, I would love to extend my gratitude and welcome towards him. For the next session chair, we'll be having Dr. Mohammed Tahir. He is a professor at Thompson River University, Canada. His researching interests are optimization, computation, LP, IP, non-linear, discrete, stochastic, multi-objective, etc. Operation research, data mining, research interests are algorithms, inspired computing, computational intelligence, evolutionary computation, artificial intelligence, and their application to data analysis, big data, optimization, engineering problem, industrial and mechanical, control, wireless sensor network, operation research. Sir, kindly motivate our participants. Sir, you are not audible to us.
Hello, Dr.
Hi,
Mohammed. Hi.
It's a pleasure to be with you today here.
Hi.
Thank you, sir.
Hi.
Now we are moving towards the first presentation of the day. For the first presentation, I would like to call VZO for the paper title, A Picture is Worth 1,000 Words, Designing a Telehealth Solution Using Photo Illustration. Presenter, you can proceed with your presentation.
Can you see my screen?
Yes, ma'am. The screen is visible to us.
Okay. My name is Wei Zhou. I'm a research fellow from Monash University, Australia. Welcome to the presentation. A picture is worth 1,000 words, designing a telehealth solution using photo elicitation interviews. This work is about the early stage research of a digital health project in Australia. First, I briefly introduce the background of this project. It's structured around a human-centered approach to developing and validating telehealth solutions to improve care delivery in palliative care settings. As we know, palliative care aims to provide relief from the symptoms and stresses of a serious illness and to improve the quality of life for both patients and their families. So this specific setting presents distinct challenges due to the vulnerability of the patient population and the complexity of their healthcare needs. So that's why we use photo elicitation. And next, the presentation will cover the methodology, the key findings, and the implications of using photo elicitation in the telehealth project. First, I will talk about the importance of user engagement in telehealth design. Engaging end users in telehealth design is a crucial process for developing effective telehealth solutions, enabling understanding of real-world challenges faced by users, and promoting inclusivity and end-user designs. This work explores photo elicitation, which is a qualitative research method that uses photographs to capture and discuss detailed user lived experiences. This method helps in gaining deep insights into the needs and aspirations of end users, particularly in sensitive contexts, such as palliative care. This is the methodology of applying photo elicitation interviews. First, we applied for ethics approval from Human Research Ethics Committee from Monash University and other institutions because our team was a multidisciplinary team composed of software engineers, healthcare researchers, and industry partners. And we adopted a collaborative approach to align protocols and terminology. And to establish common understandings, we held regular meetings every 2 weeks to discuss the progress and the challenges. For the participant recruitment, end users were recruited from a tertiary hospital's palliative care unit, including healthcare practitioners or professionals, patients, carers, and interpreters for non-English background patients. The recruitment was very challenging due to the chronic conditions of patients and pandemic restrictions because the project commenced at the end of 2021. And at last, we secured 12 participants, including 6 healthcare practitioners and 6 patients. For the data collection and analysis, the participants were required to capture photographs based on specific prompts. And then a follow-up online interviews will be conducted between participants and the research team to discuss the photos and their relation to telehealth experiences. Analysis include thematic and intertextual techniques, combining photos and transcripts from the interview to identify recurrent themes or motifs, such as the comfort, connectivity, and care. This is the key outcomes from photo elicitation. We present the outcomes from 2 aspects. The first is patient lived experience. The second is healthcare practitioner lived experience. For patient, the benefit is the comfort of at home and reduced anxiety, especially for rural patients, because they can save the time and cost for the community. And also they can be accompanied by family members, so they will feel more comfortable. The challenges for patients is limited physical examinations, so they totally rely on the data they provided. The technical needs include the reliable internet, hardware, and training materials. For example, the camera for the video interviews. For healthcare practitioners, it's totally different because they feel physically discomfort because they might sit in a shared clinic settings and there are many background noises, so they need for telehealth support. And from psychological aspects, because of the missing physical designs, they need for better video capabilities. And the health practitioners feel social isolated. So it's very important for them to maintain interpersonal relationships with patients and also with their peers. This is a storyboard created from photo elicitation interviews. depicting various themes and motifs related to telehealth experiences. The photos were inserted into transcripts from the interview at relevant points and analyzed together using intertextual techniques. Recurring themes were identified and consolidated into categories and healthcare practitioner and patient experiences. So the top row is about patient's experience and the bottom row is about healthcare practitioner experiences. And there are three themes. The first is comfort. The second is connection. The third is care. So representative photographs and quotes from the transcripts of the interview were used to depict each theme. So, for example, for patient, this is the photo and the quotes from the interview from the patient. So generally, patients feel comfortable when attending consultations from their home environment and appreciate the ability to include family members in these conversations. But for connection, their needs, such as necessary microphones and video capabilities, the ability of the software to perform in a conservative mode in remote areas come to the fore. So most of the patients rely on the landline, so they may not be proficient in the network. And for the care, the limited opportunities for physical examination and less thorough assessment points to supplementary role of current telehealth delivery and need for a future innovation. So it means telehealth can be supplementary to the face-to-face consultation. From the healthcare professional or the practitioner's perspective, conductive technical and physical instruction is needed to make telehealth comfortable and effective for practitioners, because there may be many practitioners in the same room, so it will get very loud and everybody else will be talking over the phone. And for the connection, healthcare practitioners often found telehealth challenging from both patient connection and peer connection perspectives. So they reported feeling isolated from both their patients and colleagues. And for the care, they reported that delivering appropriate care via video consults requires special observational skills that can be strengthened with training and experience in identifying visual cues. But they believe they can finally be or get the skills of the video consultation. The discussion focused on ethical, practical, and technical recommendations for telehealth design. Addressing privacy concerns and managing emotional stress are very crucial ethical considerations. So we have to de-anonymize all the sensitive information in the photo exhibition. Practically providing preparation time for participants and focusing on photographs in discussions can enhance data connection.
Sorry to interrupt, ma'am, but you have 2 minutes to conclude.
Okay. Technically using photo elicitation to guide fine-grained requirements elicitation, such as paper prototyping or think aloud sessions, is recommended. There are several lessons learned from this work. The first is the importance of empathy in promoting inclusive design and the value of understanding user needs to drive innovation. and addressing technology innovation through user feedback. And thinking beyond the screen, considering the overall lived experience, including physical surroundings and interactions, is very crucial for effective telehealth solutions. In conclusion, photo elicitation interviews provided deep insights into the lived experience of telehealth end users, including both patients and healthcare practitioners. Future research will explore telehealth in other healthcare domains and focus on developing more inclusive solutions, which can lead to the creation of empathetic and user-centered telehealth services that better meet the needs of patients and healthcare practitioners. That's all. Thank you.
Thank you, ma'am.
Yeah, can you hear me?
Yeah.
You're audible.
Yeah, thank you for nice presentation. I have just two small questions. How you have validated this entire study?
Sorry?
How you have validated, how you have confirmed, how you have evaluated the outcomes?
Validate outcome.
Yeah,
Yes. We have a specialist to do the check of
domain
all the
expert.
photos.
So you have domain expert specialist with you. They have confirmed, right?
Yes.
Okay, okay. And on what parameters you have validated the outcomes? What are the performance metrics?
You mean the performance of the validation or
Parameter, yeah, performance parameters. Yeah.
performance parameters? Yeah. You mean the metrics?
Okay, metrics. Yeah, correct.
Yeah. Yeah. I think the metrics can be the theme in this study. For example, comfort, connection, and
Connection
care.
and care. Yeah. Okay.
Yeah.
Yeah. Got it. Good work. Thank you. Over
Thank
to
you.
Professor Muhammad.
Hi, it's a nice presentation here. Thank you. So you mentioned it's your approach here is better than traditional technique approach. Can you talk about why is better than other approach you mentioned in the beginning?
Yeah. Because this is the early stage of a large telehealth project, so we use these photo elicitation interviews to establish the user requirement. Normally, for the telehealth, we use maybe a phone, a landline phone, to discuss between patients and health practitioners. But for our projects, is based on telehealth and in palliative care settings. So we use this photo elicitation, which not only including voice, but also photos to investigate the requirement of the user needs.
Okay, thank you. So what is the next direction then you are going to move forward for this one? Because it's
yeah, actually we are at the end of the project. So we developed a add-on or a tool that can summarize the that can do the video consultation and can do the auto summarization of the conversation between patients and the clinicians.
sure. Thank you.
Thank you.
Thank you, sir. Thank you, ma'am. Before moving towards the next presentation, I request Umar John to kindly move to virtual room D. This presentation has been scheduled in virtual room D. I'm sharing the meeting link and password over the chat. Thank you. Now, I would love to move towards the next presentation. For the next presentation, we have MDD Chadurangi for the paper title Detecting Cyberbullying, Spam, and Bot Behavior and Fake News in Social Media Accounts Using Machine Learning. Presenter, you may proceed with your presentation.
Yeah, thank you so much, Karthik. Can you please let me know if my screen is visible?
Yes, ma'am, your screen is visible to us.
Yeah, thank you so much. So, hello everyone, wishing you a good day. I'm Dulakshika Chaturangi, representing Sri Lanka Institute of Information Technology, SLIT, and I will be presenting about the research we conducted on detecting cyberbullying, spam and bot behavior, and fake news in social media using machine learning. So this is the agenda we have created. I'll be covering these aspects: brief introduction, main problem and objective of this research, about the system we are working currently in creating to detect the nation for malicious activities, the mechanism behind the trained machine learning models, use datasets, the final results with background literature survey we did, future plan, and also the final conclusion. And officially starting off, I want to highlight why we actually focused mainly on these portraits very quickly. The first one, cyberbullying. So out of Facebook reported cases, 87% is about cyberbullying, and Meta has reviewed bullying in more than 50 languages, stating that they acted on more than 9 million of content. Second, we have spam, where it can actually be repeated, low quality, unwanted content in social media. It can be user-reported comments and content with numerous external links as well. And it also affects social media users due to security and privacy concerns, social engineering, trust exploitation, and social media manipulation. Moreover, it is worth notice as in 2023 Q1, Facebook removed about 1.6 billion spam content. Next one, bot accounts. It's also something that we should give attention as Facebook took action on 691 million fake accounts, and for the entire year of 2022, Facebook removed about 5.8 billion fake accounts. With that saying, Twitter suspended over 70 million fake accounts within a 2-month period. And which says that between 9% to 15% of active Twitter accounts actually are bots. The last one is fake news. It's said that mainly due to COVID-19 misinformation, Facebook removed 7 million posts in Q2 of 2020. And from analysis done, it's found that people do believe that this misinformation do have negative impact and it negatively affect their personal lives. And we still encounter this while using social media today. So I hope it gave you a picture of why we were interested in conducting this research. Now, to understand this issue deeply, we also conducted a survey by ourselves to see how these 4 main issues affect according to the security experts. And you can see the results in this graph. Misinformation at first place, spam at second, bot accounts at third, and cyberbullying at last. Hence, we wanted to come up with a detection mechanism for these problems. Actually, I did talk about the research problem which the 4 threats mentioned earlier, but can we actually identify how much a social media profile has these issues before interacting with it or even before following a certain account? Of course, if it's a public account, anyone can go through and check, but if the profile is too long, it will be very much time consuming. So if there's a mechanism to take sort of a summary report, and will be much easier to analyze and come up to a decision. And the main objective of this research is to make social media a more secure and trustworthy environment. Moving on, this diagram here is what we have created for the overall system, which we are planning to create. The user interface is a website where the user can input the social media account URL. And I want to mention that social media, we actually focus here mainly on Twitter, or now known as X. Then through the web server, an API called Amplify takes the entered URL and gets the required profile data to feed into the ML models. Then with the use of trained ML models, the system will check and provide how much the check Twitter account is cyberbullying, spam, bot or spreading fake news. Then the final output will be a summary report with the extracted information using the API. And this is about the steps we followed when training the ML models. We use datasets from Kaggle, GitHub, and pre-process them according to our requirements. And the needed features are successfully extracted, after which the dataset was divided into two parts, training and testing. And several machine learning algorithms are used to train the model, and the best accuracy given model was implemented to the system. So to talk more on the datasets we used, in the first table, the training testing ratios are given. As you can see, except for bot accounts detection, all the other datasets were divided into 80-20 ratio, and bot accounts dataset was divided into 70-30 ratio. Also, the features considered are given in the next table with the used data URLs mentioned below. Now to mainly focus on cyberbullying detection, this mainly focuses on means, and from the recent research work we read, the trained model accuracies were in 50s, 60s, and 70s. As you can see, mainly there are Visual Bird, FCM, RCNN, BGG19 algorithms tried out. And with the results we achieved, we mainly tried KNN, logistic regression, NAV-based, linear SVC, and got the best accuracy for logistic regression with 84.9%. Next, on spam detecting, there's research with the use of SVM, deep neural networks, extra tree classifier, and etc., as you can see in this slide. And with our results, we got great accuracies in 90s level with MLP classifier neural networks giving the best outcome with 98.02% accuracy. Third one, bot accounts detection. For this, past research has been done with random forest, decision tree, naive-based, BERT, CNN, and LSTM hybrid method and achieved good accuracies. With our bot detection research component, we also tried the same algorithms as random forest, decision tree, naive-based, and actually gained 91.06% of accuracy. The last one, fake news detection. Background literature we conducted for this had shown accuracy levels in 70s, 80s with the use of EANN, which is Event Adversarial Neural Networks, Spot Faker, and more as mentioned in the slide. With our results, we could get 84% accuracy using SVM, and you can also see we have tried out other algorithms as well. Next, I want to bring your attention to our overall system, which we are currently working on, named My Social Compass, because it directs you and guides you to make correct decisions in using social media with regards to the mentioned malicious activities. And it also achieves our main objective in making social media platform more secure. So as for the final output of this system, which is the overall risk of the Twitter profile, will be taken using this well-known formula in risk management, which is risk equals impact into probability. Impact is the possible severity of the outcomes if an event occurs, and it measures the damage or loss that might result. While probability is actually the chance that a particular event will occur, and it is a number ranging from 0 to 1. Moving on, as the conclusion, we want to create a system to identify cyberbullying, spam, bot accounts, and fake news at the end. And the main aspect here is to detect these malicious activities using machine learning. So we trained 4 machine learning models for each and achieved good accuracy levels. For cybersecurity, 84.9% accuracy from logistic regression. For spam, 98.02 accuracy from MLP classifier neural networks. For bot accounts, 91.06% accuracy from random forest. Lastly, for fake news, 84% accuracy from SVM. And actually, this system can be used for comprehensive background checks when recruiting employees for organizations because today's generation lives in social media. It may give a better idea of candidates than resume in some situations. Moreover, security firms can use this kind of system to evaluate threats, and financial institutions can assess risk in client portfolios, especially regarding reputational damage. So that's why this system is significant in a way. So coming to the end, these are the references we use in this presentation. Then thank you so much for listening.
Yeah, can you hear me?
Yes.
Yeah, good work. Thank you for nice presentation.
Yes, thank you so much.
Don't you think that accuracy is still very low?
Accuracy levels. But what I consider here is actually combining all these four models for the oral system. It will be a great accuracy because there are two in 90s and there are two in 80s. And with
Have you
the
compared?
yes,
Yeah, it's fine. But have you compared it with some state of the art?
state of that
State of that existing some good potential work from literature.
yeah, we actually have provided some literature we have considered yet. So
And then why you have only considered accuracy parameter? Why not other confusion matrix?
we have F1 parameters mentioned here as well. And more than that, actually F1 and accuracy levels we could achieve it. So
there is precision, there is recall, there is when it goes to the classifier, there is ROC, receiver operating characteristics, there is area under curve, right?
yeah, we actually considered those as well, but we thought of including this in the slides.
So you can also explore that so that
Yeah.
you can have better insights, right?
Yeah, sure. Yes.
Yeah, thank you.
Thanks so much.
Hi, thank you for your presentation. Nice talk here. So you mentioned about feature extraction here.
Yes.
So you have used feature extraction. Why didn't you use feature selection instead of feature extractions?
Actually, that is due to the datasets that we have used, and according to the data that is available there in the GitHub and Kaggle. So we use that approach because it was actually better.
But when you compare the other approach in the literature here, are they using also feature extraction or they are using feature selection?
Actually, they have used feature extraction as we have read in the research. So
They use feature extraction?
yes, in the
Okay.
background literature.
Yeah, because it might be an advantage to use feature selection rather than feature extractions. So maybe try and look for this approach
Yes.
here if you can use it, and look to maybe the accuracy would be better for some situation. Yeah.
Yeah. Thank you so
All
much.
right. Thank you.
Yes.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Juanita L. Bethel for the paper title Employees User Experience of Intelligent Process Automation in the Financial Sector. Presenter, you may proceed with your presentation.
Good morning, everyone. I'm
Good
just going to
morning,
share my screen quickly. There we go. That's perfect. Yes, good morning. I'm Jonita Beitel, and I am a student at UNISA, the University of South Africa. Our presentation focuses on the user experience of financial sector employees following the implementation of intelligent process automation. Myself, Jan Kruse, and Donnie Bishops are the authors. In this presentation, we will briefly discuss the research background, focus, and methodology, and then we'll share the empirical results. If we look at the research backgrounds, our key terms are the fourth industrial revolution, financial industry, user experience, and the need for research in these areas. The fourth industrial revolution represents the current era of connectivity, advanced analytics, automation, and manufacturing technology. It combines human behavior and technology seamlessly, emphasizing digitalization as a critical element. The financial industry urgently needs technological enhancements to boost competitiveness and efficiency. Financial institutions are embracing complete digitization with intelligent process automation as a solution. Automation, integration, and the reliance on technology significantly affect user experience and technology acceptance in the workplace. This paper focuses on the employee user experience of intelligent process automation within financial institutions, addressing the uptake and the use of obligatory systems. Given the profound impact of the fourth industrial revolution on financial sectors, there's a pressing need for research into employee user experience of intelligent process automation. In this research, we focus on why employee user experience is important when intelligent process automation is implemented in the financial industry. Prioritizing user experience is crucial because it significantly impacts the user's satisfaction and their willingness to use a system. In the financial sector, user experience influences employees' intention to continue using applications. Intelligent process automation involves rule-based task automation, incorporating artificial intelligence and emerging technologies. In the financial world, intelligent process automation has become essential, reducing or eliminating employee intervention in labor-intensive tasks. Recent attention focuses on integrating user experience into intelligent process automation within financial institutions. Users' acceptance of technology remains a concern despite its acknowledged importance. Intelligent process automation's financial advantages positively introduce technology uptake from an organizational perspective. Automation frees employees from routine tasks, enhancing efficiency and job satisfaction. User acceptance is crucial to the success of automation and depends mainly on the technology's perceived accuracy, reliability, and consistency. When users trust technology, their satisfaction with the automation will likely be higher. Looking at the methodology we followed, in this research applies an interpretivist philosophical paradigm to understand the social context of user experience. It uses semi-structured interviews to allow flexibility while exploring specific topics. The participants in this study were selected through purposive sampling to ensure valuable data aligned with the research purpose. The interview answers were transcribed, cleaned, and qualitatively analyzed using atlas.ti in a thematic analysis technique. The analysis highlighted 5 themes that were important to the employees who make use of the intelligent process automation in their daily activities. These themes include the user expectations, the challenges that exist in automating existing systems and processes, the influence of automation's outcome on users, the impact of automation on the user experience, and ultimately on the users themselves. We'll be delving deep into each one of these themes. Employees and the organization have preconceived expectations of what the intelligent process automation will achieve. The first expectations are already created in the automation assessments. Employees participate in the performing of an automation feasibility analysis. They identified high volume transactions, task repetition, and standard rules as the crucial criteria for automation assessments. Employee goals for automation focus on reducing their workload and improving work-life balance, while the organization focused on reducing workload. While the organization aimed to enhance process quality, speed, and accuracy for the client experience. Employees expect a dual benefit from an automated system. They want to experience decreased stress levels and increased process effectiveness. Organizational expectations were connected to the improvement of existing manual processes, focused on enhancing efficiency, accuracy, and cost effectiveness. The expectation of cost saving was significantly, particularly in a financial institution. The journey towards full integration and acceptance of intelligent process automation required employees to interact with digital workers. Although some employees overestimated the capability of automation, others were cynical and anticipated its failure. Positive expectations included collaboration, consistency, ease of use, efficiencies, and user-friendly system integration. While negative expectations included process failure, job losses, lack of control, and resistance. These expectations directly influence the user experience outcome. The implementation of intelligent process automation had positive and negative outcomes. Automation had a positive impact on employee well-being, and job security improved due to streamlined and efficient processes. Employees experienced positive emotions such as confidence, excitement, and trust, and reduced stress levels and fear were observed. The benefits of automation included improved task efficiency, standardization, and reduced reliance on human involvement, and employees had a more significant responsibility in the end-to-end process. Due to time efficiency and streamlined processes, reports could be generated more quickly. The streamlined task allowed employees to focus on value-added activities. A remarkable positive outcome is the enhanced job satisfaction and productivity. Automation fostered opportunity for engaging in complex, fulfilling work, and employees saw automation as a gateway to continuous learning and growth. The negative results of implementing intelligent process automation included distorted user expectations and dissatisfaction. Employees expected error-free processes without any human intervention, and high success rates were anticipated. Users found that automation could make mistakes, but they also acknowledged that errors often result from the information provided to the system. Some of the negative feedback was due to overly optimistic expectations. Some automated solutions didn't add the expected value. The next theme addresses the impact of intelligent process automation, specifically on the user experience of the employees. Positive feedback from the employees include improved ease of use, the attitude toward automation and technology, and the career opportunities provided by the reduced manual processing time. Automation improved efficiency and saving time for critical tasks. The participants experienced excitement and confidence due to successful outcomes. Users started to trust the automated system to run as intended and notify them only when necessary. Reduced anxiety were associated with manual
Sorry to interrupt, ma'am,
errors.
but you have 2 minutes to conclude.
Thank you. Users also shared negative user experience. They felt frustrated by their limited control over the automated processes and their lack of understanding about system limitations, which led to a sense of helplessness. Doubts about automation's ability to replace human tasks and fear that widespread implementation would reduce employment opportunities. Despite the benefits, addressing user experience and limitations is crucial for successful automation. Implementing automation in the financial sector brought significant changes to the workforce, including a shift in skill sets, increased employee engagement with technology, and strengthened teamwork. Automation also positively affected workplace security, reliability, and decision-making. Additionally, the advent of intelligent process automation expanded the scope of tasks and jobs that machines can perform. Thank you so much.
Thank you, ma'am.
Thank you.
Yeah, thank you. Can you hear me?
Yes, I can.
So which operations you have considered in intelligent process automation?
Within the financial institution that the empirical study was done, they make use of robotics, robotic process automation
Process automation.
specifically,
Okay.
as well as artificial intelligence.
So any specific vertical from the industry you have considered for your study?
Any specific article?
Yeah.
Sure. Yeah, there's quite a few. I can't pinpoint one specific one.
So it's a very general study you have carried out, right?
Yes, it is. This forms part of my PhD studies, which is following a design science research methodology. And this is the second phase of the design science study.
Design. In one of the slides, you mentioned user expectations. So how you have measured user expectations?
These were through the interviews. We ask the users, what do you want this automation to do? What do you expect it as the end result? So there was no measurement put in place. This was asked in the interview what the actual users are expecting.
Okay. Through interviews, you have tried to measure whether there is to the expectations or not. Fine. Fine. Thank you.
Thank you.
Thank you, sir. Tahit, sir, do you have any questions?
No, thank you. Thank you.
Thank you,
No
sir.
question. Sure.
Thank you, Doctor.
Thank you, ma'am. Thank you, sir. Now we are
Thank you
moving
very
to the
much.
next presentation. For the next presentation, I would like to call Valerigis Melalos for the paper title Fuzzy Equivalence Relation as Similarity Measure in Egonometric Color Clustering Algorithm. Presenter, you can proceed with your presentation.
Hello. Oh, can you hear me?
Yes, sir. You're audible to us.
Yeah. Now I will share my screen. Okay, you can see. Yep.
Yes, sir. Screen is visible to us.
Yep. So my name is Valeris Mikhailos, and I'm PhD student from University of Latvia. And so my topic is how fuzzy equivalence relation can be used in clustering algorithm. So firstly, briefly, motivation of work. So when we have a clustering problem, the typical measure used for clustering is distance. So if we have some observation, the usual approach can be following. You introduce some centroids, and next what you do, you are assigning observation to clusters those centroids are closer. Or another way could be you're measuring the distance between observations, and if the distance is small enough, you're appending these observations in the same clusters. Or you can choose another method, but in mostly methods, you will use the distance measure. And here you can see examples of commonly used distance measures. So here is Euclidean distance, the most popular distance often used in various applications. Here is the city block distance, also known as Manhattan distance. Interpretation of this distance is very simple. It shows the number of horizontal and vertical moves required to reach one point from another. Here is the Hamming distance. This definition is provided for binary vectors, and it shows the number of different components for two vectors. So these distance measures are chosen based on the nature of the data and the requirements of clustering tasks. So, and we will consider the clustering task with measure that is inverse of distance. It is similarity measure. So if distance between observation is not large, then the similarity measure will be high. This approach has benefits when we are dealing with datasets with outliers or some variations in data, because similarity measure is less affected by extreme values, so it can lead to more stable clustering results. And for constructing the similarity measure, we will use a tool which is called an additive generator. It is a one variable function that is continuous and strictly decreasing. And here are some examples of additive generators for different t-norms. So for the product t-norm, an additive generator is a logarithmic function. For the Lukasiewicz t-norm, an additive generator is a linear function. And here is also an additive generator for Hamacher t-norm. It is following. Here, depending on the parameter R, we get different additive generators. And in special cases, when parameter R is equal to 1, we get the result the same as was for product t-norm. And now, how exactly we will construct the similarity measure? So to construct the similarity measure, we will use the following theorem. For any pseudometric, such mapping is a t-equivalence. So the theorem can be proven using the definition of t-equivalence by checking this mapping for reflexivity, symmetry, and transitivity. And here is an example of a construction similarity measure for a product t-norm. So first, we find the inverse function of additive generator. And then using this theorem, we are constructing equivalence relation. So similarity measure that we got is strictly decreasing fuzzy equivalence relation. And the same process can be applied to another t-norms. And now we will consider two types of fuzzy similarities, internal and external. By internal similarity, I mean similarity which is calculated for observation from the same cluster. And external similarities are calculated for observation from different clusters. And also here is similarity that represents how similar is not observations, but clusters. So in general, clustering problem becomes we are maximizing internal fuzzy similarities for each cluster, and at the same time we are minimizing the cluster similarity. And here are provided fuzzy similarity for some t-norms. In previous slides, it was shown how to construct the similarity measure for a product t-norm. And here also you can see how similarity measure is defined for Lukasiewicz and for Hamacher t-norms. And now let's take a look how we will evaluate the similarity measure for two different clusters. So if we have two clusters, which in general may have more than just one combination of external similarities. And now using the aggregation operator, we are aggregating all these external similarities into single similarity. And this aggregated similarity will represent how similar are these two clusters. So from aggregation operator, we are asking two conditions. Operator must be monotonical. It is the first condition, and operator must satisfy these boundary conditions. And also, this aggregation operator is based on additive generator. And here, depending on the chosen t-norm, we have different clusters similarities. Here are the cluster similarity for Lukasevich t-norm, for product t-norm, and for Hamacher t-norm. And as I said before, here we are aggregating only external similarities. And now the important step is to estimate the quality of observed clustering system. So to do that, we will use an index which is composed of two components. The first component calculates clusters' internal similarities, which we are maximizing. And the second component calculates clusters similarity, which we are minimizing. So in the end, we got following quality index for clustering with fuzzy similarity as a difference of these two components. And the closer the indicator is to value 1, the better is separation of clusters. This index may have also the negative values. It indicates that a clustering system, what we got, is very poor. And now about the clustering algorithm. So we will use algorithm of agglomerative clustering. So it means that at the beginning, each observation is considered as an isolated cluster. And in each iteration, we calculate all combinations of cluster similarities, and two clusters which have maximal similarity are merged into one cluster. And also, to merge clusters, we will use some fixed similarity threshold value. It's denoted by E mean. In each iteration, we check if the maximal similarity measure is greater than a similarity threshold, when we can merge clusters. If this statement isn't true, then we stop clustering process and clustering is done. So algorithm is pretty simple. And now let's take a look how it works on data. So clustering was performed on 3 datasets. Datasets was taken from Kaggle repository. So here is a mall customer dataset, Iris dataset, and Apple's quality datasets. So here is provided some basic information about datasets, observation count, features, and real number of clusters for each datasets. So here we can see dendrogram of agglomerative clustering for mall customers datasets using equivalence relation with Lukasevich t-norm. Here on the top, each observation is isolated cluster, and this dendrogram shows cluster iterative merging process, so depending on cluster similarity threshold. And now we are fixing the similarity threshold. It means that if in some iteration the maximum cluster similarity is less than fixed similarity threshold, when we stop clustering process. So here with a threshold 0.52, we see the threshold line crossed dendrogram in 5 points. So we got 5 different clusters. So this threshold value usually is set based on expert opinion. And here we are playing with similarity threshold and by changing it. So here with similarity measure 0.45, we got 4 clusters. So these 2 clusters was merged into one clusters. So here is cluster system with similarity threshold as 0.60. we got 7 clusters. So this cluster was split into 2 clusters, and the same, and this cluster also split.
Sorry to interrupt, sir, but you have 2 minutes to conclude.
Yeah. And here, here provided for 3 datasets results depending on clustering methods, and to evaluate performance, I used 4 different indexes: accuracy, a normalized mutual information, average rate index, and potential function, which was introduced here. So here, values close to 1 means the cluster system is very good and clusters are good separated. And as we can see, for more customer datasets where we have only 2 features and the clusters are easy separatable, the standard clustering algorithms such as k-means and fuzzy c-means shows highest metrics. But if we have dataset with large number of features and complex patterns, k-means and fuzzy c-means works still good, but as we can see, clustering with fuzzy equivalence relations, here's last 3 columns, here's Lukasevich product and Hammerhead norms. So clustering with fuzzy equivalence relations now shows where their metrics are increased. So here is a hypothesis that clustering with similarity measure could better recognize complex patterns in datasets. So in the end, here is some points what have been done in this work. So it was shown how fuzzy equivalence relation can be used in clustering process as a similarity measurement. So clustering using fuzzy similarity was compared with the standard clustering methods. Also, it was shown how that clustering with fuzzy similarities can recognize patterns in complex datasets. And also here was shown how fuzzy equivalence relation can be implemented in hierarchical clustering algorithm. But in general, it can be implemented in all clustering algorithms where is used the distance measure by replacing distance by similarity. So this fuzzy equivalence relation can be implemented in lots of algorithms. So from my side, it's all. Thank you.
Yeah,
Thank you, sir.
Thank you very much for excellent presentation.
Yeah.
Just I have a small question. So all these mathematical formulas are derived by you, or is there any base from which you have tried to derive all these mathematical formulas for, similarity of clusters?
No, similar. You mean this one formulas?
Yeah.
So we have initial base for an additive generator like this. So if we have additive generator for product t-norm, so this formula is well known for
Right. No, I'm talking about the next slide formula where you try to measure the similarities.
And in the next slides, all formulas becomes analytically from these formulas. It was written by me. It was calculated by me. So here is the formula how to calculate the fuzzy equivalence relations. So in this step, we got a similarity measure for product norm. It is defined. And in next
how you have validated? How these formulas are validated?
You mean
my question is, how you have verified whether these formulas derived are correct? You got my question?
Yes, I got your question. No, I have also my this formula, all this formula was checked by a professor which is coordinating me in my PhD student.
Okay.
So
So that
this
was my
formula
question. Good
yeah.
work. You please continue this, and you can also have some good patent on this. Right? All the best.
Mhm. Thank you.
Thank you, sir. Tahit, sir, do you have any
Yes.
questions?
Yes, I have just maybe one question here. So it's thank you so much for the very good presentation here. So my question here is, when you mentioned in the first slides about the different type of distance to measure the point here. So are you using optimization algorithm to look for the minimum distance or the maximum distance here? Or which optimization algorithm that you are using to measure the distance here?
No, here for calculation the fuzzy equivalence relation, it was defined here. So here you can see in the fuzzy equivalence relation here it becomes the distance measure. So for a distance measure was I chosen two types. I tried to use Euclidean distance and also the city block distance for experiments what I showed.
But you try to find the minimum distance, right? Between for this one Euclidean distance or the other, to try to find the minimum. Is that correct? In order to make separations, or you are not?
The minimum I used the minimum distance I used for I will show this example. So the minimum I used when I need to all observation in one cluster terms, their distance must tends to minimum. But if we are checking, if we are looking distance between clusters, so then distance must be maximum.
Yes, I know. But I was curious to know the algorithm, but that's okay. Thank you.
Thank you,
It's
sir.
a nice
Thank
one.
you, sir.
Thank you.
Now we are moving towards the next presentation. For the next presentation, I would like to call Marcela Fernanda for the paper title Multiple Linear Regression Application and Multicollinearity, a Bibliometric Analysis. Presenter, you can proceed with your presentation.
Good morning.
Good morning, ma'am.
Ok. Saludos. Yo les saludo desde Ecuador. No hablo mucho inglés, por lo que mi presentación va a ser en español. Bueno, nosotros tenemos una investigación realizada por un grupo de profesionales respecto al tema de el modelo de regresión lineal múltiple con su aplicación en la multicolinealidad. Dentro del objetivo de esta investigación, se buscó analizar la producción científica sobre la regresión lineal y el análisis de multicolonialidad en cada uno de los modelos realizados para la predicción o el análisis de diferentes variables. Dentro de lo que es el modelo de regresión lineal, fue aplicado o los papers que se analizaron fue en función a que sea una variable predictiva con respecto a varias variables independientes. Por eso el modelo que se analizó, solo los modelos que se analizaron fueron los modelos de regresión múltiple. Tomando en cuenta que cada uno de estos modelos formulados tenga la prueba de multicolonialidad dentro de lo que es un problema que se ha detectado en varias de los papers, que no se analiza la multicolonialidad en las variables independientes.
Ma'am, excuse me, ma'am. Sorry to interrupt, but I request you to use English as your first language.
Excuse me.
I request you to please speak in English.
Ask question. Read in chat.
Yes, ma'am. For presentation, kindly use English as a language.
Okay, in English presentation, I'm speaking Spanish.
Ma'am, I'm requesting you to please speak in English for the presentation, as the people are from different backgrounds, and English is one of the language that will be easier for us to understand. Thank you.
Okay, finish? No? Continue?
Karthik, it's okay. Let her continue because she will not be able to speak in English. So we can read from the slides. Is it okay, Professor Tawhid?
It's okay, yes. Okay.
Yeah, because we can read from the
No
slides and
problem.
we can go. Yeah.
Sure.
Continue or finish?
Yeah, continue. Please continue.
Thank you. Entonces, les comentaba que este análisis se enfocó netamente en los modelos de regresión múltiple y el análisis de multicolonialidad para probar el modelo. Esta información fue para un análisis bibliométrico siguiendo la metodología de el BiblioShine y el Bibliometric de RStudio, a través de un buscador o de las palabras claves en lo que se respecta a regresión, multicolonialidad, múltiple y lineal. La base de datos que se identificó de Scopus fueron de 541 artículos científicos en los años de 1982 a 2023. La verificación de las fuentes fue producción, citación, autores relevantes, países, evolución en la temática. Estos fueron los parámetros en los cuales se filtró el análisis bibliométrico. Los resultados más importantes que se logró obtener fue 541 papers, la tasa de crecimiento anual de información o de papers en este área fue del 9.28%. Los documentos elaborados por cada año relacionados a este tema son 4 documentos al año. Las citas por cada uno de estos documentos es de 21 citas por cada documento en promedio. Los autores que se dedican a realizar dentro de esta área o investigar dentro de esta área fueron 2.174 autores. Las coautorías estaban relacionadas al 24% de coautorías. Y el tema de producción, estamos hablando de 4.300 papers al año. En el tema de producción, el tema de crecimiento anual, podemos ver desde 1982 que existe una producción científica en este tema casi lineal, pero a partir del 2021 existe un pico de producción con respecto a este tema y creciente a lo largo hasta el 2023, que sigue un patrón decreciente, como se puede ver en la imagen. Tenemos las citas por año dentro de los países que investigan mayormente en esta área. Lideran Estados Unidos con el 21% de los papers, seguido de China con el 15% de la producción, y el resto de países, que representa el 36%, que se agrupan los 66 países que están involucrados, liderando pues la producción en este tema Estados Unidos y China. Existe una colaboración internacional con respecto a este tema, no siendo solo a un sector o a un país determinado o países determinados, sino existen coautorías internacionales, dentro de las que más figuran las coautorías es entre Estados Unidos y China, que mantienen una mayor frecuencia de colaboración e importancia con respecto a conocimientos y métodos probados en los modelos de regresión lineal múltiple. Las fuentes más relevantes, tenemos 12 artículos en H-Index, citas tenemos de 6.316 citas, tenemos un factor 8 en los artículos, y algo que tomar en cuenta que solo 3 artículos están aplicados en diferentes campos, desde sensores remotos hasta psicología. El tema de los autores más relevantes, tenemos desde autores desde el 2014 que han ido aumentando su producción y las citas por cada uno de los autores. Como veíamos, desde el 2021 comienza un incremento bastante alto en esta producción. Las disciplinas o los temas correlacionados a los modelos de regresión lineal múltiple están con el tema de multicolonialidad y machine learning. La evolución del tema se ha ido asentando en la predicción del comportamiento de las variables. Los modelos de regresión lineal dentro de los papers, los resultados a los que llegan siempre están enfocados a predecir el comportamiento de la variable. Dentro de lo que es el modelo de regresión lineal, ha estado enfocado bastante en el tema humanos, y los modelos predictivos enfocados al machine learning. Como análisis general de esta investigación bibliométrica que se realizó, tenemos un crecimiento significativo en investigaciones de regresión lineal múltiple con respecto al análisis multicolonialidad desde el 2011, teniendo el liderazgo, por supuesto, de Estados Unidos y China en la producción e investigación colaborativa. Investigaciones exitosas de métodos clásicos de modelos de regresión lineal múltiple con técnicas modernas de análisis de datos. Ahí existen papers incluso con topología analítica, pero buscan siempre la persistencia y la adaptación de métodos estadísticos para predecir el comportamiento. Dentro de lo que pueden ser futuras investigaciones, se pueden explorar nuevas temáticas para manejar o aplicar la multicolonialidad en contextos de Big Data, también en métodos híbridos que combinen el modelo de regresión lineal múltiple y algoritmos de aprendizaje profundo. También se pueden generar investigaciones sobre la aplicabilidad del modelo de regresión lineal múltiple en campos emergentes como la inteligencia artificial y la ética. Thank you.
Thank you, ma'am. Sir, do you have any questions? Parikshit,
No,
sir?
no, Karthik, sir, no.
Thanks, sir.
No.
Tahir, sir, do you have any questions?
No, thank you.
Thank you, sir.
Thank you.
Now, we are moving towards the next presentation. For the next presentation, I would like to call Ayat Dehri for the paper title, Searching the Balance Between Privacy Data Preservation and Lung Disease Classification Efficiency. Presenter, you can proceed with your presentation.
Good morning, everyone.
Good morning, sir.
I will share my screen now. Do you see the presentation?
Yes, sir. Your screen is visible to us.
So I'll start. Sorry. 1 second, please. So, hello everyone. I'm Ayad Dahri, computer science engineer. I will be presenting to you on behalf of the other authors, Dr. Kavani Adnan and Dr. Mahmoud Kemi and Karim Hamoudi, our research topic entitled Searching the Balance Between Privacy Data Preservation and Lung Disease Classification Efficiency. For the table of contents, we will begin our presentation with a brief introduction and motivation behind our topic, research topic. Then I will outline our proposed methodology, followed by a discussion of our experimental results and evaluation, then conclude with key insights and implications. So let's kick off with the introduction and motivations. Current regulations impose restrictions on sharing medical data publicly due to concerns about the security and privacy of patient data. However, in the AI era, providing medical data is crucial for training machine learning. So our focus lies in addressing this challenge. The main issue is the lack of training data, especially medical imaging data. The solution here is so basically it's anonymize the training data so that we can share it publicly. That means removing patient and identifying information from images, which might lead to a better privacy, but there is a risk of deleting critical information from the images, which can lead to reduced efficiency in the subsequent models. So there is here a trade-off between the privacy and the efficiency of deep learning models. Our focus is on mitigating the membership and fairness attacks, which is a lesser explored threat in the literature concerning medical images. This attack aims to identify whether a data point was used in the training phase of in the training data of a target model, potentially compromising patient information. So we took the worst case scenario where the attacker has access to the architecture of the target model and its weights, but he has no knowledge about the training dataset. So the first stage, he will collect training sets from, he will collect data from different sources that will be used to train different shadow models that have the same architecture of the target model. Then for each shadow model, he will use the training set that was used already in the training of shadow models and save its prediction with label in, which means it's been used in the training of the shadow model of our shadow model. On the other hand, the test set was not used in the training of our shadow model. So we save its prediction with the label out. Then concatenate both these to obtain our attack data set that will be used to train our attack model, which is a binary classifier. Then we will pass to the final stage where the attacker will get a query of samples of images, then use it as input to our target model. Then we will pass the predictions of this target model to our attack model to classify whether it was used in the training phase of our target model or not. So to mitigate this risk, we propose to reduce the reliance on original data during training by incorporating synthetic data as shown in this pipeline. Our approach involves using the generated by Percept network GANs to generate synthetic data from real images and use it later to train deep learning models. Specifically, we implemented the conditional GAN and enhanced it with self-attention layer, both in the generated, shown here in the blue circle, integrated both in the generator and discriminator, specifically to capture a spatial dependency that are separated spatially. So thereby aiming to enhance the utility of the generated images. So self-attention conditional GAN, SAT-GAN. For the experimental results and evaluation, for our data set of National Institute of Health, comprising over 5,000 images across two classes, normal and pneumonia. This data set was used to train both generated adversarial network and CNN classifier. Our evaluation is structured on three aspects. The first one is the evaluation of generated images quality. Visually, we can see both GANs generate realistic images. Then we will pass to the other metric, which is the fresh interception distance, which is basically the distance between a feature of real images and the features of the generated ones. So when we have a lower FID, means a better quality. Here we see that the CGAN have lower FID. That means that CGAN generated images closer to the real ones than SAGAN. But then we can rely only on FID. So we pass to another aspect, which is the evaluation of classification accuracy after GAN augmentation. Basically, we trained the CNN model on real images. Then we pass images generated by SAGAN and images generated by CGAN as a test set, then calculate the accuracy. Here we can see that the SAGAN is slightly better than the CGAN, which means that the SAGAN preserve the features of each class better than CGAN. Then for more certainty, we versed the approach where we trained two CNNs. The first one is trained using 4 SAGAN generated images, and the other is trained using SAGAN generated images. Then we pass the real images as test set and calculate accuracy. Here we see that the SAGAN outperform the SAGAN in a better way in the classification task. So in classification efficiency, SAGAN has overpowered the CGAN. Now let's pass to the final evaluation, which is the evaluation of privacy preservation level. We trained five classification models, and then we perform membership and fairness attacks on these classification models that will be considered as target models. The first one is trained using only original data, 100% original data. The second, 50% original data and 50% data generated by CGAN, conditional GAN. The third one, 50% original data and 50% images generated by SAGGAN. The last two, 100% generated images SAGGAN used in the training, and the other is 100% images generated by SAGGAN. So here we use the attack model accuracy. The attack model accuracy here, when we have a lower attack model accuracy, that means better privacy. We can see that the ones when use the augmentation using GAN has better privacy preservation values here. We can see also that the CGAN is slightly better because he has the lowest values of attack model accuracy. That means in terms of privacy data preservation, the CGAN outperform SAGGAN. Here we talk only against the membership and fairness attacks. So in a conclusion, we can say that that we investigated the use of CGAN to protect data against membership and fairness attacks, and the GAN-based methods demonstrated the effectiveness against diverse attacks, specifically the membership and fairness attacks. We also focused on using conditional GAN for high-quality chest X-ray image generating. Then we examined also the impact of integrating self-attention layers into the CGAN architectures, which already improved the utility of the images generated. Then we proposed to minimize the original data size in the training stage to overcome the risk of membership and fairness attacks, while searching to balance between the data anonymization and classification efficiency. For future suggested works, we intend to extend the approach to lung disease analysis from CT scans. Thank you for your time, and I will listen to your question.
Thank you, sir.
Thank
Sir, do
you.
you have any questions?
Yeah, just one question, quick question. Which activation function you use here?
Where exactly? Where I used in the CNN classifier, I used the sigmoid activation function because it's
And
to calculate
how many epochs? How many epochs?
for the CNN 50 epochs.
Okay, okay. And have you compared it with some existing case study?
For the CNN, for the CNN classification, I compared. I choose the best solution, which is this CNN classifier, this architecture. Also for the CGAN, I chose the CGAN based on research made in MIT University that shows that the use of CGAN in lung disease classification, lung disease chest X-ray image generation is better option, is the best option.
Fine, thank you. Thank you.
Thank you.
Thank you, sir. Tawhid, sir, do you have any questions?
Yeah, thank you for a nice presentation here. So my question here, did you compare your approach with other approaches from literature here to show what you are doing is better or why significant?
So as I mentioned, thank you for your question. As I mentioned, the membership and fairness attacks is less explored in the medical imaging topics. That's why I didn't find quite a paper that I can rely on to compare it with my with the results that I got. I'm talking here only on membership and phenotype tags in medical images topics.
Even for other classification, you said you are using 5 classifications, but did you see other classifications? You should that is the one you should really compare or use in your for comparison.
Here the classification. Here the.
I know that's the 5
class-
that you mentioned. Yes, I know.
The 5 that I mentioned are based. They have the same architecture. They have the same architecture of CNN. Only the only difference is the training data used to train.
Yeah, yeah.
I didn't. So I choose the CNN, the basic CNN, based on results that I got on some papers that the
Yeah.
CNN is have the best performance in classifying lung disease lung diseases, and then I use the same architecture for the five models. The only difference is here in the training data. That's all.
Yeah, thank you.
Thank you, sir.
Thank you, sir. Thank you, sir. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the 8th version and all the previous 7 versions of the conference. We'll be happy to have you in the 9th version in 2025. All the presenters would be getting their digital certificates through email within 2 working days. Further, all papers have forwarded to Springer. The publication will be live within 6 months. Kindly cooperate with the team of World S4. I also thank our session chair, Dr. Parikshit, for chairing the session. Sir, this is a token of appreciation from the team World S4 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence. Sir, I request you to address our participant, please.
Yeah, thank you, Karthik. Thank you all presenters. It was a very wonderful discussion, deliberation, and presentation. All have presented very nicely, and as rightly said by Karthik, please be a part of 9th version of WordForce S, and we'll be happy to have you again in the 9th version of this. So congratulations all authors, and thank you GR Foundation for having this wonderful conference as a 8th version, and looking forward to see you again in the 9th version. Over to you, Karthik. Thank you.
Thank you, sir. Now, I would love to extend my gratitude towards our next session chair, Dr. Mohammad Tahir. Sir, thank you for chairing the session. This is a token of appreciation from Team World S4 and Global Knowledge Research Foundation and partners. Sir, kindly address our participants.
Well, I echo Professor, the chair of our session here. I really so it's a real pleasure to be with you here and for wonderful and excellent presentations. And I'm hoping that we'll see you next year for the same conference here and with very better result and more result. We are curious to see this one for next year. Thank you for your anticipation, and thank you for all the people anticipating this conference to make it successful. Thank you.
Thank you, sir. Thank you, sir, for your valuable presence. Now, I request everyone to turn on their cameras for a quick snapshot of the virtual conference. I request everyone to please turn on their cameras for a quick snapshot of the virtual conference. Thank you, everyone. Stay safe. Take care. Bye-bye.
Thank you. Bye. Bye.
Bye.
Bye-bye. Thank you, sir. Thank you, sir.